maybe I say a zombie bites Will. He turns into a zombie. Today, there's one zombie. Tomorrow, how many zombies are there? Two. It's if each of those two zombies then bites somebody, how many zombies are there the next day? Then if each of those zombies bites somebody, so pretty soon we have an apocalypse, right? So what's happening is I'm starting to inch my way up slowly, but then all of a sudden it gets really big really fast, okay? And so this is what the graph of an exponential growth looks like. Now, with that said, we can also have an exponential decay, okay? And y'all have probably done this in, I don't know, chemistry maybe? Like a half-life?
Definitely not in chemistry.
Y'all have not done that in science yet? Half-lives?
Of course you remember everything.
If something decomposes by half of the amount each day, right? Does it ever really go away?
Yeah.
No. Okay.
It's
10. Cut it in half. Cut it in half. 2.5 or 5 over 2. Cut it in half again. Is it ever completely gone? I can keep on. So that's what we call exponential decay. And what happens is it comes in and it starts to even out. I can keep cutting it in half. It's never actually gone, right? I started with 10. Then I had 10 over 2, which is 5. And then I had 5 over 2. And then I had another, no, that would be 5 over 4. And then I'd have 5 over, half of that would be 8. Half of that would be 5 over 16. And I'd get really close to 0, but I'd never actually be 0, right? So it comes in close, close, close. So that's exponential. So it starts out big and then dips down and then it starts decreasing very slowly. Okay. So this one is growth. Growth. Exponential, yeah. This one is decay. Now, with that said, I can also have some reflections where I reflect it over the x-axis, right? So sometimes growth may also look like this, or decay could look like this. This is still growth and decay. It's just reflected over the x-axis, okay? So there's what they look like. Now, we talked about this little value that it's approaching. That's because what?
Well, that the decay is starting from there, going down.
So the decay is on the right side and goes down the left.
Yes, that's why it says decay. Growth on the side.
Yeah, but that one's going up.
It's been reflected. It's been reflected over the x-axis. So if I take this,
So just decay is an L-shaped growth.
if this was my x and y axis and I reflected it over, it would look like that.
Okay, what I'm trying to say is if you reflect the growth over the y-axis, it's the same thing as decay.
Yes, but you can't. Huh? No. Okay, don't worry about this right now. Right now, just worry about these two. Then we'll talk about the reflections and stuff. Okay, don't worry about them right now. Don't worry about them right now. Let me talk about some other things before I jump to that. Oh my gosh, the little dashed lines on here. The little dashed lines on here are what? Does anybody know what they're called? Just so I just tell you.
The x-axis.
They're asymptotes, bro.
They are. So, do you know what an asymptote is?
Yes.
No. Okay, so an asymptote is an invisible boundary.
Oh, I bet you Jason. Jason, can you put the description of the
That the graph can never touch. I've got it dashed because it's not actually a part of the graph, but it is there. I have to recognize it. So I'll have you graphing the asymptotes here so that you can see where your boundary is. It gets really close, but it never touches. It's an invisible boundary. The graph never touches or crosses. Asymptote.
one more time?
Asymptote.
Say it slow, like go.
Yeah, one more time.
As
No, that's not how you say it.
tote.
Asymptote.
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 There's not a Z.
There's not two S's. There's one. Like the word AS, as.
Say.
Asymptote.
My gosh.
Oh,
All right.
Just need to repeat it one more time. One more time.
Let me show you what the equation looks like so that we know how to graph it.
One more time. I need to know how to say it. If I go, I'm thinking it's terrible.
There's a shirt
Holy!
shift.
That's caught on the recording.
Hey, we cuss on the recording.
The cuss on the recording does all.
We hate the recording.
All right. A couple of things you need to know.
Sorry for the headache.
I've written this way, but sometimes, guys, sometimes there can also be a number, some random number, I'll call it C, hooked in front of this. And so whenever I reference the base, it needs to, most of the time it doesn't have one. Hey, look, it's Christmas colors. But if it's there, whenever I refer to base, you need to make sure you.
Oh, you have to memorize this?
That's a B to the C. Oh, that's a C.
Are we gonna have to remember?
Yes. Okay.
Both of them?
Now, you don't get what?
What on the letters?
You just say you
I haven't told you yet.
Hard. Oh my God, I see all that candy in there. Give me some. Don't. What? Take Thanksgiving candy.
I'm ready for my mom.
You're actually disgusting.
It's my favorite drink.
All right, the B. The B in this equation. The B tells me whether I'm growth or decay. If the B is bigger than 0, I am growth. If the B is less than 0, shut up, boys, I am decay. Oh, nope. See, you made me mess up because y'all will just stay talking.
No, I am always slouched down in my chair.
Any negative that you see is not associated with B. Instead, it is associated with A. Okay. No, I'm saying it could be written either way like this, but you look at the B, and if it has a C in it, you include that with it. But if it's bigger than 1, it's growth. If it's smaller than 1, it's decay. But the clicker here, or what am I trying to say? The clincher? No.
So we could technically do quadratic formula with this?
Dude, what does that smell?
it's not a
B, C, and A. You have B, C, and A.
What does that smell?
Literally, you fart.
God. Oh my God.
Oh my God. So it's literally how it has a fraction.
B can never be.
Yes. Yes. All right, let me tell you what the rest of the stuff is, and then we will go through and do some examples. Shut.
That coffee that one girl gave you?
Huh?
3 coffee beans that one girl gave you?
No.
You haven't had it yet?
Mm-mm.
You returned it?
No.
No, I thought you said you
I would have returned it for all the money.
All right, your asymptote.
Hey, will we do a necklace gun?
Is it a horizontal or a vertical asymptote? It's horizontal, right? You know that from here. They're horizontal. When what? Always horizontal, yes. All right.
Yeah, the crack of the ass is always horizontal.
Asymptote.
Yeah.
Asymptote. Asymptote. Say the whole word.
It's like a slang word.
All right. Well, no, it's not a slang word. We're not slanging asymptote. All right.
It's the AS part of it always.
I'm just, you know what? Always horizontal. That's why it's in the form of y equals, because horizontal lines are y equals a number. That gives me the equation for a horizontal line. And then a starting point within my graph that is always there. All right, point. And a point that is always on your graph is H, but I have to do opposite sign. And then this one's a little bit different because I have to do A plus K. All right, normally it would just be K, but here I have to add the A. Now what happens if A is not there?
Hey.
What happens if I don't see an A? What value does A have if it's missing? 1. If A is missing, then it's 1. Yes, and it's opposite H. All right, so let me pull all this together for you. This is one of the easier things that we do when we get to growth and decay. Y'all stay with me. Yes.
Oh my God.
Now,
So we got the crash. No, we're not going to grab it. So it's growth.
Here,
how do you know?
can I pick somebody? Come on, Miss McGee.
3 is bigger than 1. That tells me that it's growth, even though the number in front is 1/2. Where is the asymptote on this one? -5. So the asymptote is at y equals -5. Give me a point on this graph.
One, -2.
-4.5.
What?
H, A plus K. A plus K.
Oh, that's opposite. I'll do it. Oh.
Yes. All right, growth or decay?
Growth,
How do you know?
4/3 is bigger than 1.
This tells me it's growth. Where is the asymptote?
+7.
Give me a point on the graph. Perfect.
Don't get the hustle there.
Does it get
Getting
harder?
harder.
Doesn't know.
Just have to graph it.
We just have to graph it. Okay, so with all that said, let me show you. Some of you like to graph from transformations. Others of you just like to graph. You don't like to graph from transformations. Let me at least show you what the parent graph looks like. The parent for this one has an asymptote at 0. Say this is the parent growth. The asymptote is at 0. And I have the point 0.01. It's hard to give like a parent on this one because something like 2 to the x, okay? What I'm getting to here is because the base varies here to have a parent graph, it's kind of hard. But what I want you to see is this is the one we start shifting, okay? Based on what the base is, like the parent for this one would be 4/3 to the x, right? And then I would start doing my shifts. Up 7, left 2, reflect over x. Y'all remember doing all that?
4/3 would be like
4/3 is your base. So that tells you what your parent is, right? So for here, the parent, the 4/3 raised to the x. But every one of these have.
how does that? How does that?
I'll show you. Let me just show you without transformations. I mean, yeah, I think it'll be easier that way without transformations. All right, so let me show you how to graph. I'll do you a step sheet for how to graph. How about that? How to graph. This is my example over here. I'll do while y'all are copying this, is this a growth or a decay? How do you know?
4 is bigger than that.
4 is bigger than 1. All right. First thing I'm going to do, are y'all ready? Graph your asymptote. What is my asymptote here? 1, right? For this one, it's y equals 1. So on my graph, here's 1. Here's my asymptote. Step 2. Graph the point h, a plus k. Remember your opposite, your same, your a if it's missing. So what is the h, a plus k on this one? 2, and then a plus k, -1. Row with me? Last thing is an easy point. Same way we've always done easy point. Go one beside your h, add 1 to it. Okay, so in this case, it's going to be x equals what? 3, and plug it in to find y. Watch your order of operations here, though. By just going one past, it's going to make this exponent be 1. It's going to make it a lot easier for you. All right, exponents come first. 4 to the first power. So that's -8 plus 1, which is -7. You only need 2 points to graph these. 1, 2, 3, 4, 5, 6. Now, if I connect these, clearly this is going down really fast this way, right? Which means it's got to hug the asymptote in this direction. Why is it under the asymptote? Can't touch the asymptote, but look at your equation. Why? We said that this was a growth. Why is it below the asymptote? It's reflected. Y'all are exactly right. This negative, this is what I was trying to get you to see in the beginning. That negative tells me that it's below the asymptote. So the negative there, if you want to make a note, -a means below the asymptote. Let's do a little analysis here, because this is what you'll have to do. What is the domain? -infinity to infinity. Who put that there? Grayson, take that down.
You accuse me of everything.
Grayson, take that down.
That was not.
Go take it down.
That's been there for like 2 days.
Okay, we'll take it down anyway.
No, you're accusing me of everything. I'm not doing it.
You better not ask me to do anything for you.
I'm sorry. I didn't say that. I think I put my eraser on.
That's nasty.
I don't remember.
My dog ate Kenzie's eraser yesterday. She's big mad. Because she has a special eraser because she does canvases and stuff, and she pencils them in and she paints them.
Bro, get another eraser.
I bet her painting
It's
is
a
terrible.
special eraser.
Give you another special one.
I mean,
Womp womp.
it can't cost a lot.
Womp 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 your grade.
Well, it's great because I'm gonna go in there and I'm gonna hack it.
What's the range? What's the range? -infinity up to what? 1. Bracket or parenthesis? Parenthesis. Why is it a parenthesis? It never touches the asymptote. You cannot touch the asymptote. Okay?
What GPA would you have?
It is now.
What GPA do you have to have? Like to graduate?
How about the end behavior? As x approaches infinity, f of x negative. As x approaches negative infinity, nope. 1. It approaches the asymptote. It doesn't touch the asymptote, but it approaches the asymptote. How about, yep. Tell me when you're caught up. Not today. Huh? But as you go to the left, this graph is getting close. You're talking about what is y doing? Y is getting closer and closer to that invisible boundary. Stop it, boys. Stop touching each other. Keep your hands to yourself. 4 on the floor and hands in your lap. Eyeballs up front.
I would touch little children.
4 on the floor, eyeballs to the front, hands in your lap. You're definitely not on the ground, so you didn't fall. All right.
Did you say hands on your lap? No. My hands are on a lap.
How do you find the y-intercept?
Oh, it's all out.
How do you find the y-intercept?
Oh.
Shh, boys, y'all are distracting everyone. How do you find the y-intercept? What 0? Plug in 0 for what? For x. Y-intercept is always where x equals 0, so take your equation and plug in a 0 for x. This is what you're going to have to do for your homework, so make sure you are paying attention. F of 0 -2 times 4 to 0 minus 2 plus 1. Remember, exponents come first, okay? So I got -2 times 4 to the -2 plus 1. What happens when I have a negative exponent hooked to a number? I do. You're exactly right. So this is -2 times 1 over 4 squared, which is 16. How do I multiply a fraction to a number like that? To the top. How do I add those? 8 over 8. Same thing. And I get, there's your y-intercept. So how am I finding a y-intercept again? Plug 0 into the x. Yep.
Like one of many times that you.
Just shut up, Will. Just shut up, Will.
The first time you've ever thought actually.
All right, do we need another example, or are y'all okay?
First time you actually make.
Apparently, I finally taught well today, so